Hi everyone, myself Dr. Oliver. Today I am going to continue with the fourth video regarding automation and control system laboratory. Last three videos we discussed about the introduction and basic components and types and graphical representation, as well as the how to use FluidSim software. What are the symbols available in detail we have discussed in the last three videos. Today we are going to continue with the new concept, the continuous actuation of double acting cylinder with speed control. So what is meant by speed control? Speed control for a double acting cylinder. So why we need speed? So speed control of a pneumatic or hydraulic cylinder is accomplished using a flow control valve. A flow control valve means it's a regulate the speed of the cylinder by controlling the flow rate of the actuator. There are three different types of speed control circuits they are having. One is meter-in circuit, another one is meter-out circuit, and another one is bleed-off circuit. These basic circuits meet the varying flow control demands for systems with positive and negative loads. These three meter-in, meter-out, and bleed-off helps to fulfill the demands for system with positive and negative loads. So we have to know what it means. What it means: speed meter-in, meter-out, bleed-off. Meter-in means speed control during a work stroke can be accomplished by regulating the flow. So the forward action, it will regulate the flow. This may usually it will be useful for positive loads. It cannot provide accurate control under negative load condition. That is the disadvantage of meter. In meter out, speed control during a walk stroke can also be accomplished by regulating flow from the cylinder. So here also in meter out, we are going to give the throttling valve, or we are going to control the speed or control the amount of flow in the rod end, but we can accomplish the regulating the flow from the cylinder. The same thing we can do by keeping our flow control valve rod end. But here some advantages there compared with metering circuit. Can provide accurate control for positive and negatives. So it is in the metering, it will be useful for only positive load, but negative load it fails. But here it can control for positive as well as the negative loads. The third one is bleed-off circuits. The bleed-off circuit control design places the flow control valve in a T in the working line between the direction control valve and the actuator. So here we come across a term positive load and negative load. What is mean positive load? What do you mean by positive load? Any idea? So we can call as a opposing load or resisting load. Opposing load or the external load works against the direction of the piston motion. The external load works against the direction of the piston, not in the on the direction, it against the direction of the piston motion. Okay. For example, we can lift a cylinder weight vertically. When we are lifting the cylinder upwards, so it is against the direction of the piston. Piston motion is going to down, but we are going to work against. So that is the positive load. For that purpose, we can use metering circuit. So the load itself helps to resist uncontrolled acceleration. Speed control is achieved by regulating the air entering the cylinder. So metering control is used. The negative load, overrunning or assisting load, we can call as overrunning or assisting load. The external load works with the direction of the piston motion. That is cylinder lowering a weight vertically. For example, I am going to move down an object from a certain height. That means we are lowering the load vertically. The load forces can cause the piston to move faster because of the load. It is moving fast. It is moving faster than the air supply. Potentially lead to because of gravitational force. So because of uncontrolled movement or jerky motion will cut. At the same time, it maintains smooth control. The flow of air existing in the cylinder must be restricted. This creates a back pressure of compressed air, which acts as a cushion to oppose the overrunning load. So it is very useful for both positive load as well as the negative load. Today we are going to discuss about design a circuit to get a continuous reciprocation, and also we have to achieve a speed control. We have to use a double acting cylinder, not a single acting cylinder. Already in the last video I explained the use of single acting cylinder. Direct control you can go for single acting cylinder. Double acting cylinder, two actions we can, extension as well as retraction we can control via pneumatic system. Okay. So what are the components required for this speed control circuit? So we need a compressor line. So manifold line we are having. So from the storage we are receiving that main line. From main line we have to keep it a FR limit. Then we need a control system. So these are all supply limits. FR limit and the compressor line, the supply limit. Then we are going for a this one valve control system. Control valves we need, control elements. So there we are using 5 by 2 direction control valve. Then already in the last video itself I have mentioned, if you want to get a continuous action means you have to add some limit switches. For that it acts as a sensor. For that we are having a 3 by 2 roller operator limit switch. Then double acting cylinder we are having. So we are going to deal with only one cylinder, so only double acting cylinder is enough. Then to connect all this you need connectors and the hoses. These are all the hardware elements which we required when we work in a board. But now we are going to work with this all components we have to make use, and we have to work in a software. We use Festo Fluid Sim software version 6. Version 6 we are using to simulate this double acting cylinder with speed control. So continuous actuation of double acting cylinder with speed control we are going to simulate by make use of Festo Fluid Sim software. So here we can see the moments how it will be. So there is a different action mid in, mid out we are having. So now we see uh, if you are moving uh, when we are applying load, then during the extension we are going to regulate the flow. So restricted flow is available for extension. At the same time, when for the retraction, free flow for that purpose only we are using a check. So this flow control valve is made up of throttling with the check valve. Throttling with check valve. It's a flow controller. Throttling with check valve. All other components already we explained. We have a push button, so it's a direct control. Okay. The meter out also the same. I'm going to keep it in the rod end. So meter end, I'm keep it in the extension side. That in blank end, I'm keeping the throttling valve. For mid out, I'm keeping the throttling valve with the check valve near the rod end. Understand? I think you will be thorough in the difference between meter out and meter in. Meter in, we have to keep it here. Meter out, we have to keep it here. Okay. So here restricted flow for retraction. Isn't it? No. So you know when the extension occurs, there is a restricted flow. So it won't allow the fluid come inside. That means going out. Similarly, when you are sending the retraction also, we can have a restricted flow. Okay. Bleed off means directly without reaching the circuit itself, I am going to open it to the atmosphere. So bleed off circuit. So mostly you can use for a hydraulic circuit. So you can see the continuous actuation of double acting cylinder with the speed control. Already there is a push button 3 by 2 valve. FR unit, the same 3 by 2 valve we can have for a uh, limit switch. Limit switch 1, limit switch 2 we can have. Here we have a flow control valve with the check valve. So it is in the blank end, it is in the rod end. Okay. So now we will try to simulate in a software. We will try to simulate in a software. Okay. Simulate in a software. So you can see first you open the spreadsheet software, but you have some student session also available. You can try to get it and you can open it. Now we know all the commands. What are the commands required to execute this? Simulate this spreadsheet. continuous action. Okay. So what we need, one double acting cylinder we need. So one double acting cylinder we need. Then what else we need? One 5/2 valve we need. One 5/2 valve we need. 5/2 valve we need. 5/2 valve as a DCV. Then one, two 3/2 valves we need. Two 3/2 valves we need. So two 3/2 valves we need. So you can take one and copy, rotate it and copy it. Rotate it and copy. Paste it. So we have two limit switches, one DCV. Then we all control elements, everything okay. Now we have to go for supply elements. We have to go to the supply elements. So these are all supply elements. Here we can use compressor air supply. Then we can use air service unit. Okay. If you want in between any push button switch, you want means you can have that also. So 3/2 valve, once again you can have a 3/2 valve. 3/2 valve you can have for a push button switch. Okay. So now one by one we can connect it. So it is a compressor, so you have to connect here. So here we have to connect. So this is a 3/2 valve. What before connecting this, we have to double click and go and configure the valve. So what type of valve we need? We need a push button. So manually operated push button we need. A spring return maybe. So all others are same. So it is enough. Go for whether it is open valve or closed valve, that we have to find out. Okay, now it is okay. So double click this one, input a exhaust. Okay. Now from here we have to connect the 5/2 valve. So now we have to go for configuration of this 5/2 valve. So you have to choose some. Here also have to choose. Okay. It's not spring return. Both are automatically operated. So I think now it is correct. So anything you want to change, you can name it identification. You can name it DCV 5/2 DCV. Just like that, we can have 5/2 DCV 5/2 DCV. You can display it. Then you want to simulate any values means you can do, or currently you want to change the parameters, but you can. Otherwise, you can go for. So now, double click the DCV. Sorry, double acting cylinder. So DAV, double acting cylinder A. Configure the cylinder. So what do you need? Whether you need cushioning, adjustable, you need only adjustable or cushioning with adjustable. So whatever you want, you can add. Then you can go for profile. You want to do any analysis of means, you can go for force profile, then external load, then actuating levels. So it is cylinder A, so you put A minus, start point 0, end point 0, A plus, start point 100, and end point. Okay. So you want to show the designations or anything else, you can. Any parameters you want to change, the piston diameter, piston rod, so maximum stroke length you want to add means you can change it. Now it came. Okay. So now you can connect. Now we have a push button, so extension will occur. For retraction, we need another valve. So we can go for this valve, double click, and configure this value. So we can change this to here it is spring return. Here it is mechanically roller switch. Or anything else you want means you can add automatically related values or configuring anything you want to add. Here you can add limit switch. So, okay. Now we have to configure this one as a plus. Okay. That's it. Now we have to add all these correctly. Correctly, we have to do it. Otherwise, we can also have to. Okay. There you have to. This is a pilot operator line, so you can go to the drawing properties, change the line with the color. Color also want to change, you can choose. So now this all made. So as of now, no need. Later on I will explain. So now I think all the connections are completed. So once again we check it. So compressor to FRL to push button switch, then 5 to PCB. Then we can go for a limit switch. Then we can have a double acting splitter. Okay. So now we go for simulation. Go to home, start symbol. Okay. So now it is connected. So whenever you switch on, immediately it will go and double act. Okay. So it is not double acting. It is based on our stroke. Manually we have to operate each time. So now we have to stop it and we change it. So instead of this, we can go for change. We remove this. Okay. Remove this. Double click. We put it LS1. Limit switch 1. Then we go for configuration. Likewise, same. 1, 2. Change this into roller. Remove it. Bring it return. It is. Okay. So now we add this one here. So check it thoroughly and do it. Wait. Now from here it is going to Now this is a pilot operator line, so double click. Any name you want to put for that line means you can put, otherwise you can go for drawing properties and change it to color. Okay, then take it to the dotted line. Thick line you can have 4.2. For now, I think all the connections are over. Here it is missing, so A minus. Okay, now all the connections are over. Now once again we'll check whether it will be in continuous action or check. Go to home, start. Now see without any manual intervention, we can do all the operations. Each cycle will be so and reduce the speed means you can do double click here, go and reduce the speed. Understood? But in this, what we have to do, we have to go for speed control. So the speed control, so stop once again, add a flow control. Understood? So now it is a double acting cylinder with continuous action. Now what we are going to do, we are going to add a throttling valve. Going to add a throttling valve. Two types of valves we are adding. Throttling valve. Second. So remove this, and this. Space management is important. First you have to check the space, then you start with this. Now okay, I want to configure this means double click this and go there and put flow control valve FCV. Anything, any changes you want to do, it's here you can. Here also double click, go to FC. Okay. Now once again we'll check. It's our aim. We have to have a continuous actuation with speed control. So now we can go for checking. Go to ROM, go for this start executing, execute, start. So we can reduce the speed. So throttling speed you can reduce. Normal flow rate you can have 85. Stuff you put 50. Here also you can reduce flow rate into 20. The difference, auto action is fast. People have understood that continuous actuation with practice with in and through how speed control actually. Once again, I will mention the components: compressor, correlate, able to DCV, control one, then liquid switches one, DCV to one, then double activity. So people are so thorough in this double acting cylinder with speed control. So we'll see the next video for sequencing. In a short while we'll have a discussion of sequencing also. Thank you for your patience, listening. Thank you very much. Thank you.